Oh, thank God, at least you're alive.
We lost Stepan.
Fuck! Okay, silence.
What's up?
A sound from the tunnel. Can't you hear it? Something's approaching.
Well.
What the?
Looks like an automatic system.
I'll check it out.
Somehow I have a bad feeling about this.
All clear.
There's no other way. Gotta take it.
So, the next station is D6. Gas masks, quick!
Artyom, take my spare filter.
Alright, moving on to main category number 2, the fun part. I'm saving the best for last, of course. In the subcategory number 1, I will speak about GST. The reason why I will speak about GST is that science attempts to come up with theories to understand why the things we are seeing in the world are occurring as they are. And if their theories are consistent with the observable, they make sense. The theory is able to make predictions, then the theory is considered valid within the sciences, especially sociobiology and evolutionary psychology. Sociobiology is a field of scientific study which is based on the assumption that social behavior has resulted from evolution and attempts to explain and examine social behavior within that context. Often considered a branch of biology and sociology, it also draws from ethology, anthropology, evolution, zoology, archaeology, population genetics, and other disciplines. Within the study of human societies, sociobiology is closely allied to the fields of human behavioral ecology and evolutionary psychology. Sociobiology investigates social behaviors such as mating patterns, territorial fights, pack hunting, and the hive society of social insects. It argues that just as selection pressure led to animals evolving useful ways of interacting with the natural environment, it led to the genetic evolution of advantageous social behavior. GST is one of these theories made to explain, from a scientific point of view, social behaviors that could be considered racism, and assume that it is natural. The theory is consistent and very able to make accurate predictions, i.e., here is where science seemed to begin to accept that it is nature. Firstly, a very short history lesson on genetic similarity. Darwin proposed a competition of tribe with tribe, in-group versus out-group, to explain altruism. In 1871, on page 179, he writes, quote, "Thus a tribe of people willing to cooperate and if necessary sacrifice themselves for the common good would be victorious over tribes made up of those less willing or able." Genetic similarity theory was launched in 1984 by psychologists J. Philip Rushton, Robin Russell, and Pamela Wells. Their theory is based largely on biologist William Hamilton's earlier work. Hamilton, in 1964, launched a classic article on inclusive fitness theory to explain the existence of altruism between genetically similar individuals. The theory was later named kindred selection by the biologist John Maynard Smith, who with Hamilton's work as a foundation explained why it is an evolutionary advantage to act altruistic towards each other by genetic relatives. According to the GST, kindred selection is only a special case of inclusive fitness. What is important is the genetic similarity in itself, not the direct relative relation, something which from time to time is pointed out by Hamilton in 1975. For an example, a mulatto cousin of yours is a direct relative relation, but since you are more genetically similar to any random white person than your actual cousin, you will thus on a neutral base be more inclined to favor your more distant cousins based on you sharing more visible genetic similarities. And this is indeed what we do observe in societies. Genetic similarity theory, GST, is, as said, an extension of the theory of kindred selection. According to GST, a gene acts for their survival by securing the reproduction of all individuals who carry a copy of the gene. Organisms thus do not only exhibit altruism solely towards their own offspring and close relatives, but to all more genetically similar individuals. The greater the genetic compatibility is between two individuals, the greater the altruism tends to be. According to GST, there's also to some extent an inverse relationship, in which individuals tend to be directly hostile to genetically relatively less similar individuals, as they threaten the purity and undermine the genetic reproduction and expansion of the genes. Steven Pinker in The Blank Slate says, quote, "Natural selection is the morally indifferent process in which the most effective replicators outproduce the alternatives and come to prevail in a population. The selected genes will therefore be the selfish ones, in Richard Dawkins' metaphor. More accurately, the megalomaniacal ones, those that make the most copies of themselves. A roughly noble anything is an unlikely product of natural selection, because in the competition among genes for representation in the next generation, noble guys tend to finish last. Conflicts of interest are ubiquitous among living things, since two animals cannot both eat the same fish or monopolize the same mate. To the extent that social motives are adaptations that maximize copies of the genes that produce them, they should be designed to prevail in such conflicts, and one way to prevail is to neutralize the competition." End quote. Genes cannot be directly observed to behave, however. Rather, genes have an effect on the behavior of organisms, often complex, indirect, and flexibly modified by environmental conditions. We can only infer the effect of genes from the phenotypic behavior of individual animals or plants. Since organisms are survival mechanisms for genes, by definition, those genes that programs organisms for successful reproduction will spread. To maximize their reproduction, genes program organisms to do two things: successfully compete against and thereby hinder reproduction of organisms that carry alternative alleles of the genes in question, and successfully cooperate with and thereby contribute to the reproduction of organisms that share the same alleles of the genes. In simpler terms, the degree of cooperation between organisms can be expected to be a direct function of the proportion of the genes they share. Conversely, the degree of conflict between them is an inverse function of the proportion of shared genes. Pierre L. Vandenberg, The Ethnic Phenomenon, page 7. GST in short. GST states that a gene ensures its own survival by acting so as to bring about the reproduction of any organism in which copies of itself are to be found. Rather than behaving altruistically only toward kin, organisms are able to detect other genetically similar organisms and to exhibit favoritism and protective behavior toward these quote-unquote strangers, as well as toward their own relatives. In order to pursue this general strategy, an organism must in effect be able to detect copies of its genes in other organisms. They order several data sets with this theory, including kin recognition studies in animals raised apart, assortative mating, intrafamilial relations, human friendship and altruism, ethnic nepotism. You could almost say that some of the evidence that I have already introduced you to that shows that racism is natural are parts of the evidence that shows the GST to be valid. I will of course also introduce you to more evidence that show the more genetic component of the theory that racism is natural, and these too will be evidence that show the GST theory to be valid.
Because ever since Darwin's day, evolutionary biology has been split between those who look at the broad picture of how the evolutionary players affect each other's fate, and the geneticists, more interested in examining each of us in isolation to find out what makes us tick. The geneticists were on the brink of in understanding our individual natures. They were overturning simplistic ideas which had held back our understanding of animal and human behavior for a generation.
I can remember being taught that the reason why animals, when they're competing for a territory or a female or something, do a lot of displaying, but very seldom actually fight with claws and teeth and so on, was that if they did fight with all their weapons, that would be bad for the survival of the species. This is what is called a group selection argument. What is being selected is something that is good for the species. Even then, as an undergraduate, I knew it was rubbish, though I couldn't at that time provide an alternative explanation for the behavior I was seeing.
The problem with group selection was that it ran counter to the basic principle of Darwinism, that we are all selfish. Individuals who act for the good of the group will never do as well as individuals who act for their own benefit. The cheats in the commune will always destroy cooperation. This was the end of group selection. But if group selection didn't work, then individual selection created its own uncomfortable problems.
If the benefit of Darwinian thinking was that it immediately made sense of all the selfishness we see around us, then it also created a problem which didn't exist in the group selection paradigm. Well, what about the altruistic behavior? What about when the individual is self-sacrificing? On the group selection paradigm, well, that's no problem because it's advantageous. On the individual selection paradigm, no, it created a very definite problem.
The point is that a naive interpretation of Darwinism is that you would expect individual organisms simply to ensure their own survival and reproduction.
The key to the problem of altruism was found by looking not at the individuals, but at their genes, and asking who they shared their genes with, and what that meant for their behavior.
Everybody, in a sense, knew that what animals work for is not their own survival, but their own reproduction. Putting that in genetic terms, what it means is survival of genes. Survival of genes means more than just individual reproduction, because genes survive in other kin as well.
This was the idea of the selfish gene. Individuals have an investment not just in their own children, but their brothers, sisters, nieces, nephews, cousins, anyone they share their genes with. It is the selfish genes that give us an evolutionary reason to care about our relatives. Evolutionary scientists had taken the first steps in solving the mystery of altruism. If they could do that, they began to wonder how much more of human behavior they could explain.